Okay. So, we are discussing about this observation. So, what is the input signal index should be bit reverse? Why it is required? What is the problem? If you see, when I say n equal to 8, how do I club the signal x0 with x4, x2 with x6 and index 1 signal we clubbed with index 5 signal, and this is the jumble things I required, x3 with x7. How do I do that? In case of 8 point, I have done it, but let us say n equal to 1024 point. So, if n equal to 1024 point, it is impossible to do it manually. So, how can I disseminate the input signal xn for computing FFT? So, when I want to implement the FFT algorithm, I know I have to implement the butterfly, and each butterfly I require input signal which are jumbled as an odd and even, If in case of 8, I know this kind of jumble is required, this kinds of dissemination is required in the time. So, in case of 8, I can odd and even, I can do that. But in case of n equal to 1024, how do I do that? That requires itself an algorithm. So, instead of reducing the complexity, I am increasing the complexity. So, how should I do it? If you observe minutely that there is a trick to access the signal, which index of the signal should I access? Let us first explain for 8 bit, then I go for the other. So, let us say n is equal to 8. So, if I say x of n, the index of the signal, the sample number which is represented by the index of the signal, this n, if I want to represent in binary number, how many bits is required? So, what is the maximum value of n? N by 2 minus n minus 1, which is nothing but a 7. What is the minimum value? 0. How many bit required to represent 7 as a decimal number? So, I know 3 bit. So, if I say 3 bit can be represent the index of the signal for 8 point DFT, or the length of the signal is 8. So, 0 0 0 0 0 1. So, this is 0 decimal, this is decimal and this is binary. This is 1, 0 1 0 2, then 0 1 1 3, then 1 0 0 4, then 1 0 1 5, then 1 1 0 6, 1 1 1 7. So, the index 0 is represented by a 3 bit binary number which is 0 0 0, all 3 bits are 0. Index 7, all 3 bits are 1. I want to access the signal in this order. So, first 0th sample, then 4th sample, compute the butterfly, then 2nd sample and 6th sample, compute the butterfly. So, how do I decide that what should be my accessing sequence, so that I can club 0th sample with 4th sample? It says that if I access the index in bit reverse mode, so this is B1 bit, this is B2 bit, this is B3. So, this is LSB, this is MSB, B1, B2, B3 is the LSB to MSB. If I access it instead of B1, B2, B3, let us say B1, B like this way. So, B1, B2, B3 this side, I reverse it. So, B3 becomes LSB and B1 become MSB, which is called bit reverse. So, here I reverse the bit reverse. So, I reverse the index representation bit. So, if I reverse it, what will be there? 0 0 0. So, 0 0 1 LSB become MSB 1 0 0. So, this is 0 1 0 0 and again LSB becomes MSB 0 1 0, again 1 1 0. So, again 0 0 1, again 1 0 1, again 0 1 1, again 1 1 1. Now, see that access 0 4. So, if I access the signal in index bit reverse mode, I get 0th sample and 4th sample which I required. Similarly, here 2 sample, 6 sample, here 1 sample, 5th sample, here 3 sample, 7 sample. So, if I access the index, so I store the signal in a memory and I am accessing the signal in bit reverse mode of the index. So, the decimation which is required in time domain is done in bit reverse mode. Understand? So, I do not have to write and separate algorithm for to disseminate the signal in time domain. I directly get it by accessing the signal in bit reverse mode. So, that is the beauty of FFT algorithm. So, if I summarize, then what is the computational complexity of an Radix-2 dissemination in time algorithm? So, I know I require every stage I required n by 2 number of butterfly, and number of stage is nothing but if n equal to 2 to the power v, number of stage is v. Every stage n by 2 number of butterfly, and one butterfly required only one multiplication and 2 addition. 2 addition, 1 multiplication. So, if I say that how many multiplication? Number of stage is v, each stage number of multiplication is n by 2. So, nothing but a v into n by 2. What is v? V is nothing but a log 2 n. So, I can say computational complexity is n by 2 into log 2 n. So, if I say n is equal to 1024, then total number of multiplication is 1024 divided by 2 log 2 1024, which is nothing but a 1024 divided by 2 into log 2 2 to the power 10, which is nothing but a 10240 divided by 2. Okay. So, number of multiplication reduce. Now, if you see how do I disseminate the signal in time domain? So, in 8 bit I know it is 0 4. So, here n is 1024. So, if I say how many bit is required to store the index n of x of n? 2 to the power 10 means 10 bit is required. So, I can say this n is represented by 10 bit. Let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bit is represented by 10 bit index, and it is stored in a memory location. When I accessing the signal for doing FFT, I will access it in bit reverse mode. So, whatever the index n is varies from 0 to n minus 1. So, I get the n, take the bit reverse, then access the signal, corresponding signal will be accessed. So, when I accessing 0th signal will be accessed. When I see accessing 1 signal n equal to 1, I just done the bit reverse. So, whatever the index will come, I will access that signal and I compute the FFT algorithm. So, what I request all of you, once you understand the Radix-2 dissemination in time algorithm, can you implement in C programming? Do not write the FFT of signal in MATLAB and do that. Can you do that? Later on you can think that how efficiently I can implement it. Okay? So, that is the dissemination in time algorithm. Now, we go for the dissemination in frequency algorithm. Here, so instead of dividing the signal odd and even, in time domain, now I dividing the signal in frequency domain. So, what is the frequency domain? If x of n is in time domain, then capital X of k is in frequency domain. So, instead of dividing x n, I am dividing x k. Let us I compute that x k, first k equal to 0 to n by 2 and then n by 2 to n minus 1. So, I can say instead of directly computing n point DFT, I divided this DFT equation in 2 n by 2 point DFT. First I access the signal x 0 to x of n by 2 minus 1 and compute DFT. Then I access the signal x n by 2 to n minus 1 and compute the DFT. So, this is the DFT number 1 and this is the DFT number 2. Now, here I can directly know, okay, this is nothing but the same, but if you see here summation is varies from n by 2 to n minus 1, but the length is n by 2, I know that. But if I say that this index is changed to n plus n by 2, then I can say small n equal to 0 mean x of, okay, you may not be understand it. So, I will take a slide here and then I explain it very clearly. Then I come to this slide. So, what I said, forget about the slide, what is there, forget about that. So, I said I want to compute n point DFT. So, x k is equal to, you know, n equal to 0 to n by 2 minus 1 x of n w n n k. That is the DFT equation. Now, I said, so instead of dividing the signal in odd and even, I said no, I want to divide x k in two parts. One x k is x k where n, so where I can compute the x k where my x n will varies from 0 to x of n by 2 minus 1. So, I write down that part first. So, n is varies from 0 to n by 2, sorry, this is n by 2 minus 1 x of n w n n k plus another DFT x k, which is when the n is x of n is varies from x of n by 2 to n minus 1. So, I can say n varies from n by 2 to n minus 1 x of n w n n k. Now, if you see this, look at this one. Here index n is start from n by 2. Let us suppose I want to start from 0. The meaning is that the index is changed from, instead of index n, I can write n plus n by 2. When I write n plus n by 2, then I can rewrite like this way, n equal to 0 to n by 2 minus 1 x of n w n n k plus n equal to 0 to n by 2 minus 1, because length of the signal is n by 2. Now, I want to write 0 instead of n by 2 to n minus 1. So, what I am doing is that I am changing the index, which is nothing but a n plus n by 2. When n equal to 0, I am accessing x of n by 2. When n equal to 1, I am accessing x of n by 2 plus 1. So, this part I am doing. So, n index is replaced by n plus n by 2 into k. So, if you see that w n n plus n by 2 into k, which is nothing but a w n n k into w n n by 2 into k. So, what is w n n by 2? So, it is nothing but e to the power minus j 2 pi by n into n by 2. So, 2 cancel, n cancel. So, e to the power minus j pi, which is nothing but a minus 1. So, I can say it is nothing but w n n k into minus 1 to the power k. minus 1 to the power k. So, what I can say that x of k is equal to n is varies from 0 to n by 2 minus 1 x of n w n n k plus n varies from 0 to n by 2 minus 1 x of n plus n by 2 into w n n k into minus 1 to the power k. So, if I say that this one is an DFT, length is n by 2, this one is an DFT, length is n by 2. So, if this one is f1 k and this one is f2 k, then I can say x k is nothing but a f1 k plus minus 1 to the power k. So, there will be another term, I have forgot it. Okay, let us see this one f2k. Okay. So, I write down f1k is nothing but a, this part I write down, okay. So, now if you see that, so I can say that x of k here, x of k is equal to this two sum is same. So, why I write two sum? Let us say n equal to 0 to n by 2 minus 1. So, f1 can f2k almost equal same. So, I can say f n equal to 0 to n by 2 minus 1 or n minus 1. Up to this part is okay. Okay. So, let us say, so x k, forget about this slide, think about here, x k is nothing but a f1 k plus minus 1 to the power k f2 k. Okay or not? So, if it is that, so when sometime x k will be f1 k plus f2 k or x k will be f1 k minus f2 k. So, when this will be plus, when k is even. So, if I say x2 k, in that case it will be positive. If I say x2 k plus 1 for odd, if k is even, then it is f1 k plus f2 k. If k is odd, then it is f1 k minus f2 k. So, if I want to write down the equation of f1 x of 2 k is nothing but a n equal to 0 to n by 2 minus 1 x of n w n n k plus 2k w n 2k k equal to 2k plus n equal to 0 to n by 2 minus 1 x of n plus n by 2 into w n k is replaced by 2k n. So, if you see, I can say that n equal to 0 to n by 2 minus 1 x of n plus x of n plus n by 2 multiply by w n n k 2, which is nothing but a, this can be replaced by w n by 2 n k. So, which is this is signal and this is n by 2 n k. So, it is nothing but a n by 2 point DFT. Whose n by 2 point DFT? I will take another slide here. I can say x of 2 k is equal to k is equal to n equal to 0 to n by 2 minus 1 x of n plus x of n plus n by 2 into w n by 2 n k. So, I can say this is signal, let us say this is g of g1 n. So, g1 n is nothing but a x of n plus x of n plus n by 2. So, I am creating a signal sequence accessing the signals g x of n plus n by n plus n by 2 signal. Okay. So, these two signal combined together create my g1 n, and then I can say n equal to 0 to n by 2 minus 1 g1 n w n by 2 n k. So, it is nothing but a n by 2 point discrete Fourier transform. Now, when x is odd 2k plus 1. So, for odd index of frequency, even index of the frequency this one. So, what is the odd index of the frequency? I know this is nothing but a n equal to 0 to n by 2 minus 1 x of n w n to the power n k, n into 2k plus 1, k is replaced by 2k plus 1 minus plus minus 1 to the power 2k plus 1 into n equal to 0 to n by 2 minus 1 x of n plus n by capital N by 2 into w n to the power 2k plus 1 into n. So, I can combine together n equal to 0 to n by 2 minus 1 x of n. See, this is 2k plus 1 is odd, is nothing but a minus x of n plus n by 2. Okay. W n to the power 2 k n into W n to the power n, 2 k plus 1. So, this is nothing but a n by 2. So, this is, if it is G2 n, then I can say this is again n by 2 point DFT, n by 2 point DFT, and which is multiplied by W n to the power n. So, if the output is odd, then it will be subtract and 2 point DFT, the n by 2 point DFT. If output is even index, then it will be add and n by 2 point DFT. So, if I want to draw the signal flow diagram, so I have x0, x1, x2. So, here I am not disseminating the signal. Signal is accessed as per index x0 plus x of n plus n by 2. Okay. So, see that how the signal is flow. When I computing dissemination in time, my signal flow from last side, this side to this side. Here I am flowing the signal from input to output. How? So, 0 to 3, 4, 5, 6, 7. So, if I say this is my k index 0, k index 1, k index 2, k index 3, k index 4, k index 5. So, if I say this is an even index, this is an even index. Okay or not? So, if I say that first part, let us say this part is even and this part is odd. So, I have divided x k, x of 2 k and x of 2 k plus 1. So, 4 point will be even point and 4 point will be odd point. Let us say this first 4 point is my even point, which is k equal to 2 k, and last 2 point is my odd point, k equal to 2 k plus 1, last 4 point. So, in case of first 4 point, it will be signal x0. So, what is g1 n? g1 n is equal to x of n plus x of n plus n by 2. So, if it is 8th point, n is equal to 8, then I know that n by 2 is 4. So, when I say accessing x0, then I have to access x of 4. So, x0 and x4 will be multiplied, add together. Okay. There is nothing, nothing is there, just add. Now, again when I say x of 1, then I know it is nothing but a x of 1 plus 4, which is 5. Add together, add together, add together. So, first 4 point is my when x of 2k. Second 4 point is x of 2k plus 1, which is negative. So, I know that is g2n is equal to x of n minus x of n plus n by 2. So, when I say this index n is, so in this case this will be, if you see the first one and last one negation minus. Okay. So, instead of plus I have make it minus. So, I get this one. Now, once I get g1 and g2n, then I know g2n has to be multiplied with wnn. Okay. So, n is varies from 0 to 4. So, w to the power 0, 1, 2, 3. So, you see that dissemination in time, weight vector multiply, then add and subtract. Here first add and subtract and then weight vector multiply, then propagated for the next section. Again it will be 2 propagated for the next section, because n by 2 points. So, it will be w8 to the power square. So, I get that jumbled version of the output. So, if you see the output sequence is in bit reverse mode. Output sequence is in bit reverse mode. So, if I want to access the output sequence, I have to do the bit reversal and I get the sequence. So, when I want to do the x0, then x1 I access the index in bit reverse mode, I access that x value. So, this is called dissemination in frequency. Is it clear? So, dissemination in time and dissemination in frequency, this is the two algorithm, you have to know it, and maximum use cases is time and some cases frequency is also used. So, which one is convenient, you can use it. Now, if you see there is a Radix-2 algorithm. What is Radix-2 algorithm? Radix-2 algorithm, I know that n can be expressed as a 2 to the power v. Radix-2 algorithm, n is expressed in 4 to the power v. So, I can say if n is equal to L and m, so if L is equal to 4, then I know m is equal to n by 4. So, I have divided the signal in a 4 sequence. Instead of 2 sequence, I divide n by 2 sequence, I divided the n sequence in a 4 sequence. Similarly, if I say in dissemination in time, so I divided the input signal in 4 sequence. When I say dissemination in frequency, I will get the output as an division. So, input sequence I am not jumbled, it is as it is given, and output sequence I get in jumbled order, which is in bit reverse mode, I access it. Okay. Most common uses case is Radix-2 algorithm. Mostly used algorithm is Radix-2 algorithm. Is it okay? So, I will stop here. So, I have explained the time domain, the Radix-2 algorithm, dissemination in time and dissemination in frequency. I will request all of you, please implement it, and if you have any confusion, write down it and then learn it and try to develop an algorithm on it, and you can implement that algorithm using C programming. Okay? Thank you very much.